Hi guys, this page is all about finding the equation of a straight line, and to do this today we're going to use a form of writing an equation that's called the slope-intercept form. So when we have an equation in this form where we've got y equals something times x plus a constant, we call that slope-intercept form, where the m represents the slope or the gradient, and the c represents the y-intercept. In different countries they use different letters other than these, so you might see it written down as y equals ax plus b, or even some other letters sometimes. I'm not really sure why we use m for gradient, nor c for y-intercept, to be honest, but that's what you'll find in most revision guides and videos in this country. So rather than part A and part B for each question, I've just written part M and part C, so it's easy to see which one is which. So for this first graph, for this first equation, the gradient is 3. And remember, the gradient is just the number in front of x, the coefficient of x. It's not 3x, the gradient, it's just 3. And the y-intercept is 1. On part B, the gradient is 2, and the y-intercept is -5, and so on. I'll pause the video here, complete the questions, and you can unpause when you want to mark your work. Okay, there's the answers for question 1. Let's have a look at question 2. Okay, on question 2, we're not given the equation, but we are given a gradient and y-intercept, and they want us to write down the equation, so it's just doing the reverse. So all we're going to do is we're going to take this number, we're going to put that in front of x, and we're going to take the y-intercept and we're going to use that as a constant after the equation. So a constant just means it's not multiplying by any of the variables. Okay, if you've got any negatives, just make sure you include their sign as well in front of them. So this one has a gradient of 2, positive 2x, but a y-intercept of -1. So rather than writing plus -1, I'm just going to write -1. Okay, again, pause the video, press play when you want to see the answers. There's the remaining answers to question 2. I've just highlighted which ones were the gradient in yellow and the y-intercept in green, and just to show you that any equations that go through the origin, there's no need to put +0, so that's why I've just highlighted that empty space as emphasizing that the y-intercept was 0. Okay, also look out for questions like E and F, where they don't tell you, they don't just say what the y-intercept is, they say it passes through 0, 4 or 0, -2. If you think about where that point would be on the on a graph, it would lie on the y-axis because the x coordinate is 0. Okay, so in a way they have told us exactly what the y-intercept is, just in a different way. Okay, on to question 3. So now we're finding the equation from an actual diagram, from a graph. So we need to find the gradient and we need to find the y-intercept. The y-intercept is by far the easier to see, so I'm just going to leave a gap for the gradient in a second, but we can see that the y-intercept for this first graph is +4, so I'm going to write +4. We need to figure out what this number in front of x is by working out the gradient. Hopefully you remember from the last lesson that we work out the gradient by doing the rise divided by the run. So the rise here is 3, the run was 1, so the gradient 3 divided by 1, 3 in this case. Okay, so you just have to do that for each graph. Pause it here, have a go at them, and we'll look at the answers in a moment. Okay, here's the answers for question 3. Note that this last one is just y equals x, because the gradient was 1, so there's no point putting 1x, and it went through the origin, or it went through 0, 0, so there's no point putting +0 as our y-intercept either, so that's just the graph y equals x, which is a 45-degree line that goes through the origin. And here's the answers to the other questions in that question. Just one thing to mention with this last one, we could also write that as y equals 3 minus 3x. And sometimes you'll see it written like that because mathematicians like to start with something positive if they have anything positive. Okay, let's have a look at the ones below. So you've just got to watch out for the changes in scale on these questions. So on the previous ones, every square was worth a number, but not on these ones. We've got 2 squares per every number on the x-axis. So there's the answers to that question. Just watch again. Just read the numbers on the scale rather than counting squares. Very important. And there's the final set of answers for that question. Okay, we'll have a look at question 4 now. Okay, remember that an equation is an explanation of the relationship between the y and the x coordinates. So that's the whole point of it. We can apply this relationship to these x and y coordinates to see whether it gives us those coordinates. Okay, to see whether if we use that x coordinate, we get this y coordinate, or vice versa. So that's what we're going to do. We're going to substitute 2 as our x coordinate in place of x. We're going to work out what the value of that gives us to see whether it is equal to the y coordinate that we were testing here. Okay, so we're going to substitute 2 in place of the x. 3 lots of 2 would be 6, minus 1 would be 5. That's what we've got as our y coordinate output, if you like, and it matches what we had here. So yes, it is on the line. Let's try the next one. Substitute 4 in place of the x, so we're doing 3 times 4, which would be 12, plus 1, which would give us 13, not 1 that we had in the coordinates. So no, it's not on the line. Okay, carry on as above, and I'll reveal the answers. Okay, there's the remaining answers for question 4. Okay, I'll go through the next page in the next video.